Okay, let's dive into this. Have you ever really stopped to wonder about the magic that's happening inside your phone or your laptop? Well, we're about to pull back the curtain on the silent, unsung hero of all your digital devices. I mean, seriously, just think about it for a second. You've got what, dozens of tabs open, you're streaming some music, maybe a video's rendering in the background, and you're typing in a document. How does it all just work? Without completely crashing and burning. What's the secret sauce to juggling all of that at once? Well, it's not chaos. It's actually a symphony. And right at the center of it all, there's this secret conductor, this invisible mastermind that's directing every single piece of hardware and software, making sure they all play together in perfect harmony. Now, this masterful conductor, it has a formal name, and it's the key to this whole impossible juggling act. We're talking, of course, about the operating system. So, what is it really? An operating system, or OS for short, is the most fundamental software on a computer. It has two absolutely giant jobs. First, it manages all the resources. We're talking the processor, the memory, the storage, the whole shebang. And second, it provides the interface that lets you actually communicate with the machine. You can think of it as the ultimate translator. It's the bridge that turns your clicks and taps into the complex language the hardware understands. In that juggling act we mentioned, it can be broken down into a few core jobs. The OS is constantly deciding which programs get to run and when, who gets what slice of memory, and how all your data gets organized into files. It also handles all the input coming from your keyboard and mouse, and all the output going to your screen. That's I/O, or input-output management. And as if that wasn't enough, it's in charge of security. It's a non-stop performance for sure. Okay, so if it's managing all that stuff behind the scenes, what services does this conductor provide directly to you and your apps? How does it make your life easier? A great way to think about it is like a personal digital butler. When you double-click an icon, it's the OS that handles launching that program. When you hit save, the OS is the one that actually writes your file to the disk. It even lets your apps talk to each other, like when you copy text from your browser and paste it right into an email. And all the while, it's also your bodyguard, constantly on the lookout for errors and security threats. Now, the way we talk to the OS has evolved like crazy. It all started with the command line interface, the CLI, where you had to type out these very precise text commands. Then came the total game changer, the graphical user interface, or GUI, with its windows, icons, and that trusty mouse pointer. And today, a lot of us use the most direct method of all, the touch interface on our phones and tablets. So we've seen how we talk to the OS, but what about our applications, like a video game or a web browser? How do they ask for these powerful services? Because they can't just do whatever they want. They have to ask for permission. They use something called a system call. This is the official, formal way for a program to request a service from the OS kernel, which is the absolute core of the operating system. It's kind of like a program raising its hand and politely asking, "Excuse me, Mr. Operating System, would you mind saving this file for me?" Let's just walk through it. Say you hit save in your word processor. Okay, so your app sends that system call. Instantly, and I mean instantly, the computer switches into kernel mode, which is this special, all-powerful state where the OS has total control over the hardware. Think of it as the system's God mode. From there, the OS carries out the request, writing the data safely to your hard drive, and then just as quickly, it hands control right back to your app. It's the seamless and secure little handshake that happens millions of times a day. And this brilliant separation is maybe the single most important security feature in any modern OS. Your apps, they all live in user mode, which is like a sandbox space with really limited permissions. They can't just go snooping around in memory or directly mess with the hardware. But the OS, it's the only thing that lives in kernel mode, the all-powerful control room. This boundary is the fundamental reason why a buggy web browser doesn't just crash your entire system. It's absolutely crucial. Right, so null operating systems are built the same way. Just like with buildings, there are different architectural philosophies, different blueprints for how to structure that all-powerful kernel. Early systems like MS-DOS had what we call a monolithic structure. It was basically one giant jumbled program where any part could talk to any other part. Not great. This evolved into a layered approach, which organized functions into these distinct levels for a bit more order. A more modern design is the microkernel, where the core is kept as tiny as possible, moving other services outside to really boost security and stability. So we've seen what the OS does and the different ways it can be built, but none of that matters one bit if it can't get started in the first place. So how does it all begin? What's happening in those first few seconds right after you press the power button? It all starts the moment you press that power button. A tiny program that's hardwired onto a chip, it's called the Bootstrap program, wakes up. You can think of it as the computer's ignition key. Its one and only job is to find the main OS kernel on your hard drive and load it into the computer's memory. Once that kernel is loaded, it takes the driver's seat and starts all the essential services. The final step is launching that login screen, which is it officially handing the machine over to you. So the crucial point here is this. Every single time you use a computer, you're interacting with this incredible, wildly complex piece of software. The operating system really is the true unsung hero, the foundation that makes everything else possible, silently managing a world of complexity just so we can simply click, type, and create. So it's pretty clear the OS was essential for taming the chaos of the personal computer and then the smartphone. But the world just keeps getting more complex, right? In an age of artificial intelligence, billions of connected IoT devices, and these vast cloud networks, what new kinds of chaos will the operating systems of the future need to conduct? And what will that new symphony even sound like?